In this tutorial, we're going to take a look at GeoGebra's tools for line relationships and polygons. Our line relationships is the fourth icon on our screen. It has several items in its submenu, including perpendicular line, parallel line, line bisector, angular bisector, tangents, polar or diameter lines, and locus. We'll leave the tangents, polar and diameter lines, and locus for a later tutorial after we've covered circles. Perpendicular line, that's the default tool. Perpendicular line does exactly that. We will create a line. So let's create a couple of points and put a line through them. And again, we don't always have to select that. That can be automatic. There we have a line AB. It's labeled in lowercase a over in the left side of our drawing pad or our graphics window. Now, to draw a perpendicular to it, we need to decide where we want it. If we want it through one of the existing points, then we'll select our perpendicular tool, and as it tells us in our explanation bar or our prompt, choose the point and the line that you want it to be drawing a perpendicular to. So let's choose point B, and let's have a perpendicular drawn to that line. And there's our perpendicular drawn through B, perpendicular to the line AB. In a similar way, we can also draw a perpendicular from an outside point. So let's create a point not on the original line. So let's put a point right here, point C. We can draw a perpendicular from point C to the line AB in exactly the same way, again choosing our perpendicular line tool. We'll first choose our point, a point outside the line, and then choose the line, and once again we have a perpendicular, but this time to the line from an outside point instead of from a point on that line. Let's clear our screen up a bit. We'll just back up a couple steps. Okay, we still have our line AB showing. And let's go to the next tool, the parallel line tool. Our prompt tells us that we need a point and a parallel line. Well, a parallel through A or B wouldn't be awfully helpful, so let's create another point anywhere out here. There's a point C. We want a parallel to that original line through point C, so we click on point C. We click on our line, and there's our parallel. And again, this can be done for any line or point that you have. Obviously, you would want your point to be not on the line. Moving back to our toolbox again, let's move down to the line bisector tool. Now, the line bisector tool is actually more than just a line bisector. Technically, we should call it a segment bisector tool, but here's how it'll work. It tells us in the prompt 2 points or one segment. Okay, if we click on point A and again on point B, we get a perpendicular bisector of the segment between points A and B. Now, if we have a segment, which we will now create, let's create a segment through 2 points, and I'll just create it by click and click. We'll now create a perpendicular bisector to the segment DE. We can do that 2 different ways. Selecting our tool, 2 points or one segment. Okay, so we can click on point D, we can click on point E, and there's our perpendicular bisector of the segment DE. Again, let's undo that and do it just slightly differently. Our segment bisector is gone, but this time we'll use the same tool, but instead of clicking on the 2 endpoints, D and E, we'll just click on the segment itself. And again, we get our perpendicular bisector. Let's start with a clean screen again to take a look at the angle bisector tool. Of course, to bisect an angle, we need an angle, so let's create an angle. We're just using the angle or the line tools, and they obviously intersect. Now we'll choose our angular bisector tool. It tells us in the prompt to choose 3 points or choose 2 lines. Let's do the 3-point approach. Point A, point B, and point C. And there we see that we have a new line labeled C, which is the bisector of angle ABC. Now, let's try that a little different way. Let's back up a step and see what happens if we just click on the 2 lines. So we still have our tool selected. We'll click on line A, we'll click on line B, and this time we have a little different result. Because the program had no way of knowing which angle we're referring to of the 4 possible angles, it shows us all the angular bisectors of both angles, the vertical angles formed by the 2 lines A and B. Okay, now let's clear back another step. If we had had 2 segments, we would have seen exactly the same behavior. So let's try that just to compare. Segment AB, segment BC. The same thing will happen here if we choose our angular bisector, and if we choose segment AB and segment BC, we still get lines C and D now that would be bisecting angle ABC, and also all the other angles, the other 3 angles that would be formed by the line AB and the line BC if they were there. Point this out here because it could be confusing to students to understand where these other lines are coming from. It can also be a valuable part of a lesson. Just know that this is what will happen when you use 2 segments. The same thing will be true if you use 2 rays. You'll still get all of the angular bisectors as if they were parts of lines. If you're working with vectors, you cannot actually bisect an angle between 2 vectors in GeoGebra. There are a couple of additional tools available under the lines properties. These include tangents, polar or diagonal line, and the locus. Those are fairly advanced and require first of all knowing about the circles, so we will treat those in a separate tutorial. In this tutorial we'll finish by taking a look at the 2 polygon tools. They're quite simple actually. Polygon itself creates a polygon from whatever vertices you select. That can be as simple as a triangle or as many sides as you wish. Let's create a simple figure here with just 5 points. Now what we want to do is create a polygon from them, so we'll just connect them in order. Now you'll notice as we move from one point to another we get a shaded area in the interior of our polygon, and we must always remember to complete a polygon you do have to go back to the starting point. So there we have our polygon, a pentagon in this case. The information here gets rather busy because we have the polygon, all of its sides are labeled, all of its vertices are labeled. In the algebra window we'll notice that we have a series of numbers here, and what you actually have, A, B, C, D, and E, are the lengths of the individual sides. From those we could set up a calculation to find the entire perimeter. We also have a last identification, poly 1, and beside it we have 15.99. That is the area of our polygon. Again, these are dependent objects because we did not create them directly. We created 5 points and constructed a polygon from them. As with all the other things we draw and create, we can drag, we can do whatever we wish to do, and as we do so we notice that the numbers change that are affected. Now as I move point A, we notice that lengths A and E change, however lengths B, C, and D do not because they are not impacted by point A. Also, although we have lots of information here, and sometimes you don't want all of that showing up, you can very easily remove that. The editing features and the coloring features are all covered in another tutorial when you get to the various aspects of properties of a given object on your GeoGebra window. And finally, let's take a look at the other polygon tool. We'll back up a few steps here. The other polygon tool is the regular polygon. The regular polygon allows us to create 2 points. 1, 2. Now when we choose the polygon tool and choose those 2 points, a pop-up window shows up and asks us how many points do we want, or how many vertices total in our regular polygon. Let's choose 7. And it can be virtually any number within reason. Let's apply it, and what we have is a regular polygon now. This is a 7-sided polygon. Let's move it down to where we can make more sense out of it. And that is exactly what we wanted. It is a regular polygon. And again, we can move points B and A, and the polygon will behave accordingly. I can move point B, I can move point A, I can move the entire polygon by clicking in its interior. I can also try to click on B or C or D, that is points and other sides, but the only ones I can actually move are going to be points A and B because they are my free objects. Everything else created is actually a dependent object that came from the original positioning of points A and B. And that concludes our review of the line relationship tools and the polygon tools.